with the today's eminent speaker, Mr. Bhanwar Bishnoi sir, is the Senior General Manager R&D in Schneider Electric Company. On hearing his last knowledgeable session, he is now going to continue with the introduction to Raspberry Pi and implementation of IoT with Raspberry Pi using Python. So I welcome sir to continue with his insights. Welcome, sir.
Thank you.
Please
Thank you very much.
continue.
Yeah.
Yes, sir. Please continue, sir.
Yeah, sure. Thank you. So, thank you very much for this opportunity. And I will start my presentation. Just a minute. Hope my screen is visible.
Yes, sir. Clearly visible, sir.
Okay, sure. So thank you very much. And now the today's session 15, I think it might be one or here there it changed, but the topic is Introduction to Raspberry Pi and Implementation of IoT with Raspberry Pi using Python. So as you all are aware about, Raspberry Pi has been founded in I think 2012 or something by a Cambridge University, startup company for making the academicians and students to learn computer programming in a easy way, and it's like a single board computer. So a lot of evolvement has happened also in Raspberry Pi, the Mango Pi, or maybe the kind of there are so many versions also. So maybe I will take it through. So the outline is Introduction to Raspberry Pi, then Python and electronics, and then Linux. I mean, because Linux is also a kind of a operating system which is being used, and like Ubuntu and various kind of Apache, etc. So it gives a lot of rich, programming advantage, as well as the lot of resources which is available on the single chip computer. So what is a Raspberry Pi? The University of Cambridge Computer Laboratory, which was they felt like decline in the skill levels, and designed for education, because earlier the programming was very elite kind of job, which everybody was not able to get into it because there was so much entry barrier and difficulty. But this Raspberry Pi has made it like students, like programming very reachable to students, and they can learn very quickly, and they can experiment, they can try, they can run the code, and so it gives a lot of advantage, and that is where I think it has become very popular also. So a credit card size PC, which is like you can say a credit card size computer, which has all the features of any single board computer, and plugs into a TV or monitor. So you can use a TV or monitor also as a kind of display. So it like whatever available things in home you can use, and inexpensive, like $35 each, while there are $5 also Raspberry Pi Zero. I mean, like that is also I think $5, and I think lot of localization also are going to happen, and people are trying, even in Indian one startup in Pune. I think they are also trying to localize it and reduce the cost further. I mean, the capability is like programming and electronic projects, office, play HD videos, etc. So it's a very powerful and rich single board computer. Now, who introduced Raspberry Pi? So Raspberry Pi Foundation, as a Cambridge University like a startup or a kind of a company, and formation was in May 2019, and the founders were David Braben, Jack Lang, Alan Mycroft, Robert Mullins, and Eben Upton. So these were the founders, and then founded at Caldecott, South Cambridgeshire. Registration number was 1129409, and it was like a charity kind of legally organization. So because that is where I think they wanted to reach it to every student, and like increase the computer knowledge as well as the programming capabilities. So Raspberry Pi in India also there are like as I mentioned in Pune there is one company who is trying, and you can see this campus component there are I think a lot of options are available, and they are available in Indian rupees very cheaper. And then Mango Pi also is another organization. So all winner D1 processor which is having 1 gigahertz single core 64-bit built in on open source RISC-V architecture. So and RAM can be from 512 megabyte to 2 gigabyte. Also the MQ Pro, which carries ports like 2 USB, Type-C, HDMI, Wi-Fi and Bluetooth, along with the 40-pin GPIO. So Pi compatibility to be confirmed. I mean that to function the solo, there is also a carrier board in testing with the Ethernet and USB types. So now if you see Raspberry Pi models released over the years, so like Raspberry P1 model A, that is like maybe US dollar 25. P1 model A plus, that is around $20. Model B is 35. Model B plus is 25. Then model B is again so I think P2, yeah, P2B is like 35. P3B is like 35, and P1 zero that is $5, and Mango I think is around 22. So variations of Raspberry Pi hardware platform, Raspberry Pi Zero, which is $5, and Raspberry Pi 2, Pi 3 with Wi-Fi plus Bluetooth. So software platforms like Noops and Raspbian, Third OS, and the kind of the downloads you can get from Raspberry Pi.org. You can have a lot of downloads, library, and other things. So kit components, the essential is Raspberry Pi board, then prepared operating system SD card. You need to have SD card, which is there, and then USB keyboard, then display with HDMI, DVI, or composite inputs, and then power supply. Highly suggested extra includes USB mouse, internet connectivity LAN cable, then powered USB hub, and the case. Case is like a plastic or kind of housing, mechanical enclosure. So programming language, Raspberry Pi Foundation recommends Python to be used as a programming language for Raspberry Pi boards. And any language which will compile for ARM v6 can be also used as an alternative. And installed by default on the Raspberry Pi, C, C++, Java, Scratch, and Ruby. So challenges and opportunities, new operating system, Linux, and open source, all almost tools and softwares are free. Rich resources on the web due to its popularity. Then resources link is Raspberry Pi camp.org. Then Pi educational document also are available at the above link. Then PNet, centralized user accounts and file storage system for a Raspberry Pi classroom. The Linux is like interesting and powerful operating system. Variations in the Linux are Ubuntu, Debian, Feroda, and Red Hat. So, and the command line, it works on command line principle. Raspberry Pi, Raspbian, Debian based, PNet is Ubuntu server plus Raspberry base. Linux robust, secure, and easy to use and powerful. And even Linux real time also is also available. Linux, which is called as a Linux RT. So Linux has like normal Linux and Linux RT also. If there is a response time and everything you want to have a deterministic, then maybe you can even choose for Linux RT. Then Raspberry Pi in primary education. So it has become so popular that even primary education also people are you might have seen the junior code or coding junior kind of some program which was there very popular on the internet, and they had been trying to encourage the coding practices for kids below 10 or 12 years kind of age. So setup is we need to insert the SD card, page 3 for how to prepare the SD card. So there is a process which is defined. Then 2A is connect display, plug in your digital TV or monitor. Then 2B is like connect display if not using HDMI, then plug in your analog TV or display. Then 3 is connect input, plug in a USB keyboard and mouse. So that is the and the connect network to your wired network, that is optional. And fifth is power up. I mean, post that you can power up. Plug into micro USB power supply. That connector is there. So now, if you see power, the 5-volt micro USB connector, so that is marked there. And this is the connector which is used for power supply, and similar to the one on a lot of mobile. We have this USB connector. Nowadays, I think USB Type C is also coming up. Then audio video. Like HDMI for audio and video works with the different kind of HDMI or DVI monitors. Then you have RCA video, which works with the old TV because that VGB or that kind of VGA. I mean the audio inputs. So that also AV can be hooked to the older generation TVs. Now 3.5 audio standard headphone socket is also there, which is this black highlighted color. And then we have a two USB 2.0 ports. So that is also for connectivity. And then you have one Ethernet 10 by 100 MB Ethernet port. So that is P1, but there are dual port also is available on the other variants. Now GPIO is like general purpose input and output. So there are 40, I think GPIOs are available. So in the other one, but here it might be 1, 2, 3, 4, 5, 6, 7, 8, 11, 12, 13, 14. So maybe 28 pin or something. Then internals is like system on chip. SoC is like nothing but a system on chip. Broadcom BCM 2835 700 megahertz. So because you might be aware about there is a ASIC, there is a FPGA, there is a SoC, and there is a MCU, and there is a MPU. So this is a kind of customized chip which has Ethernet port also on it available, and it is customized for this purpose. So hence it is called as a system on chip. So most of peripherals are deeply integrated into the single chip. Only I think you can see only one chip which is additional to this chip. So it has all the chip embedded into the only this single chip. And this is like a LAN controller, which is additionally put it outside. Otherwise, everything is on chip. Then this camera interface, CSI camera interface is there. Then you have DSI display interface, so that is also you can connect. And then SD card slot is also there. You can see it here. Up to 32 GB it supports. Then 10 uses for a Raspberry Pi, which just I wanted to highlight, like challenges and opportunities. The new operating system Linux, open source, almost tools and softwares are free. Rich resources on the web due to its popularity, and resource link is raspberrypicamp.org. Then educational and PNET is centralized user account, and so this is like kind of 10 applications, which is like 10 is Office. So you can see the LibreOffice, the document foundation. Then the another one is like programming. So you can see that here. Then Python Scratch. Operating system Linux on a bootable SD card. Fedora, Debian, and Arch Linux. So by default, supporting Python as the educational language. So by default, Python is supported with the Raspberry Pi, and any language which will compile for ARM v6 can be used also with the Raspberry Pi, though you are not limited to using only Python. And for primary age, Scratch Game Maker is bundled. I mean, that is also coming as a package with the when you purchase it. So this is a kind of a screenshot of Scratch where you can do your programming. So how to do that? So this is a screen which you can install and you can open. Then pen down, you have graphics also you have here. Now this Python code is like polygon.py. Let's say the polygon.py to draw the polygon. So it is to draw the polygon. Import the turtle. Then def polygon length and slides. For I in range sides, turtle.fd length, and then then you can use a print like let's draw a polygon. How many integer input int is input? How many sides would you like? So how many sides of the polygon you want to draw? Then how big you want to draw? Int input. How long do you want to want the sides? Polygon how big? How many input? Press a key to quit. And so below is the link where you can have a example code available. So what kind of projects? Video DJ mixture, integrated media player for your TV to fight the rampant Lego robot monster who is detected by your home monitoring webcam network, which reports also from the weather station that uses the car super bramble computer to tell the school notice board that the solar powered wireless rocket widget should be sent back to the earth. So now tinkering, GPIO's pin, if you are after an interesting electronics project, then you can get board a GPIO expansion board from the foundation for electronics project, and USB device or Ethernet hubs and AV out, and can be powered by 4A batteries also. So you, I mean, that is the alternate available to power through battery also. Now, like game console. So if you want to use as a game console, then you have that option also. So this is a typical application what you can do with the Raspberry Pi. So you can make it as a game console to use it. Now the next application is web server. You can make it as a web server also. So web server is like Apache HTTP server. So you have to use the Apache to make it HTTP web server. Then there is a Tor router. So you can make it as a router also. And Tor router so and HTPC you can you can BBC iPlayer or Netflix or like XPMC Media Center. Then Birdhouse, you can make it as a Birdhouse. Supercomputer. So anyway, it is a single board supercomputer. So you can create a supercomputer network. Then you can make it as a clock also. You can make a clock with the Raspberry Pi. And then PiBot. So this is a kind of mounted on the wheel and PiBot as a PiBot. So these are the references which I had taken for this. And now, so Raspberry Pi and Python, because Python is the primary language which is recommended by Raspberry Pi Foundation also. So where we there are different textbooks and there are a lot of resources are available. So Python programming with a lot of examples, exercise, and practical application. And the focus is to use the Python in combination with Raspberry Pi. So that's the kind of. And now I'll slightly touch upon the programming for Python. So write or edit, then run with the some input. If okay, then yes, more inputs. If not okay, then go again write and edit. And if more inputs, then again go to run and then again repeat the loop. And if no, then it is finished. This is a kind of flow chart. So now if you see here, the print welcome, then print to ACADS. So let's say hello.py, file name preferred extension is py. So that is the extension. Then user program, welcome to ACADS. That's the so now in is welcome to ACADS. Now Python shell is interactive. So Python shell you will get a prompt. Then now input is 3 plus 5. So the 3 plus 5 is equal to 8. Now is 3 greater than 5? That is a false. Then now print 3 plus 5 is 3 plus 5. So 3 plus 5 is 8. So these are user command and statements. And these are the output set. So now to interact with the Python programs, result using the print, most powerful or useful programs require information from users, name and age of for a travel reservation system, let's say example. Python 3 uses input to read user input as a string, str. So take as a argument a string to print as a prompt, return the user typed value as a string, details how to proceed user string. So now in, then 1, age equal to input, how old you are, how old are you, 35, and print you are age 35 years old. So you are 35 years old. Now type age, so type string. And a Python program is a sequence of definitions and commands, statements. Commands manipulate objects, and each object is associated with a type. So type is a set of values, a set of operations on these values, expression, an operation, combination of objects and operator. So types in Python is int, bounded integers is 732 or -5, float, real numbers 3.14 or 2.0. Let's say long integers with unlimited precision. Then str, strings like hello or c, etc. Then scalar, like indivisible objects that do not have internal structure. So int, signed integers, float, floating points, bool is boolean, and none type. None type is a special type with a single value, or value is called none. Non-scalar objects having internal structure, str. So now if you see type 500 int, then input 15, type -200 integer, type 3.1413, which is a pi value, so float, then type true boolean, type hello class string, and type 3 factorial equal to 2, kind of boolean. So typecast conversion of a value of one type to other. We are used to int float integer conversion in math. Integer 3 is treated as float 3.0 when a real number is expected, and float 3.6 is truncated as 3 or rounded off as 4 for integer context. Then type names are used as type converter function. So type conversion example, input 20, integer 2.5, 2, it is a truncated. Then 2.3 again truncated to 2, and then integer 3.9 truncated to 3. So note that the float to integer conversion is truncated, not rounding off. Because rounding off means 3.9 should have been 4 instead of 3, but it has been truncated to 3. Then float 3, 3.0, integer 7.3, it's a 7.3. So this is, I think, example. So maybe I'll now take just one more, I'll share my screen. Hope my screen is visible.
Yes, sir.
Yeah. So now Python with the Raspberry Pi. So the Raspberry Pi made physical computing and programming accessible to many. It is relatively inexpensive, and almost anyone could simply connect a monitor, keyboard, and mouse to get started. So Python is easy to start with high-level language, and it is an integral part of the Raspberry Pi operating system. So this is just I wanted to give step-by-step procedure where how we can do the working. We can work with sensor or actuator on the Raspberry Pi. So the Raspberry Pi was created as background. I think I had already explained. So this I don't need to repeat again. So it is for beginners and kids, and that's why Python is an integral part of the Raspberry Pi's operating system. In this guide, if you see what is the programming language, so if you see here, hardware, whatever Raspberry Pi board where you get, that is if you see OSI 7-layer model. So there is a hardware, platform. Then there is a kind of low-level language programming or assembly language programming. And then there is an application layer. So that is kind of a high-level language programming. So BIOS or OS, which is there, which could either machine code or BIOS maybe in the machine code, and some of the device drivers could be in the assembly language. and then application is high level language. So this is how the like the layers of the and the whatever physical board you see, that is like a kind of a hardware. So that is a hardware layer basically. So to communicate with the computer, we require use of programming language, and programming language anyway is a like engineered to communicate instruction to the machine which understand machine code. And machine language or machine code is a lower level. From that is the read and executed by the computer, and this language is comprised of binary 0 and 1. And this machine code, all instruction memory locations, numbers, characters are represented in 0 and 1. Then assembly language is implements a symbolic representation of machine code. That is to say, it replaces the 0 and 1 with the alphanumeric numbers in order to make it easier to remember. So like hex kind of file, or that Intel hex. So while they can run and execute fast, and main disadvantage is that it is tedious for humans to use, maintain, and debug. So entering the high level language, these languages are like lot of it can make it simple and which can directly understood by human, while computer understand only 0 and 1 binary. So programming language such as Java or C++ require the use of compiler, which is a program that converts human readable instruction or code into machine code and is then executed and run. So now on the other hand, programming language which is like Python is executed directly using an interpreter. So rather than needing to go through a compiler. So in case of Python, the compiler is not required. Interpreter is there, which is and the code is read one at a time, where each statement is translated into machine language and then executed. While a compiler scans the entire program and translate it as a whole into machine code. So this is the difference in Python and the kind of any C or C++ kind of compilation. An interpreter translates the program one statement at a time. So it's a line by line translation. So if you want to start a Python for the first time, so Raspberry Pi icon menu. So if like you can see this kind of Raspberry Pi icon or symbol into that screen once you install it. Now, so the menu which is there, if you click that, so this is the kind of menu which appears. I mean here, let's say the programming, education, office, internet, graphics, games, and like run, shutdown, then blue Java, then Genie Food Java, Mathematica, Mune, Node, Red, Scratch. So whatever earlier I had shown that Scratch is here. And then Sense Red emulator, Sonic Pi, then Thony Python ID. So here, like this example, I'm putting Thony Python ID. We can click here. Then it goes to it opens this screen like Thony untitled, and you can see this screen actually. So now, so one of the challenges when beginning to use Python is to need to install Python and other related software. And all this is already set up for you in the latest version of the Raspbian with the Pixel desktop, and specifically Raspbian Buster at this time of writing. So the easier way to get started is to use Thony as a new IDE, integrated development environment, and that can be easily accessed by navigating to Raspberry Pi icon menu, programming Thony Python IDE. And you will see a script editor and a cell, and then you enter a program in the script editor and run it in the cell. Let's write our own program. Then save and execute the code. Step 4. So now there is a one small example which is given here. So now A is equal to 17, B equal to 5, C equal to A into B, and print C. So variables A, B, and C you can see value 17, 5, 85. Now, so 17 5 is 85. You can see that. Run test thony.py and you get a response as a 85. Now, entering the following code into the ID, click on the save, name this file and click OK. Click on the run, down the button in the ID, and you will see the output here. Then run Python via terminal. We can run Python via terminal also. So there is a you have to click this and then you get a terminal. So you click on the terminal. Once you click on the terminal, then you get this open. And then where you have A equal to 17, B equal to 5, C equal to A into B, print C. And then you have this. So Pi at Raspberry Pi, hello world, Pi 85. So another way to write and run Python program is through the terminal. To access the terminal, click the terminal icon up the top left hand corner. Type the following command nano hello world.py. Then enter the following code. Press Ctrl plus O to save. Press Ctrl plus X to exit. And now you can run and save the script by using the command python hello world.py. So this is like again another one. A plus B, C equal to A plus B, A equal to 32.0, B equal to 4.5, and then you have this program. Then data type string. So again snack equal to cookie, and later snack then print letter. Then data type boolean. If A equal to 17, B equal to 17, A equal to B, then you can write like this boolean data types. A exclamatory is like equal to B, A is greater than B, A is less than B, A is greater than equal to B, and A is less than B. So data type list you can again see here. Then data type dictionary. When you want to access a collection of values and you know where just it is placed, then you want to use a dictionary. And so that is where like inventory equal to LED 9000, breadboards 5000, transistors 6700, and push buttons 6755. Commonly used method with the dictionary type data includes the keys and then bracket method, which will state all the keys in the dictionary, values again bracket. Then data types tuple. So colors equal to blue, green, red, tortoise, turquoise, purple, etc. Then tuples are like list in which it is collection of values, but they are immutable, which means it orders cannot be changed. So they are especially useful in cases where the value cannot be modified. Then indentation, so that is again control flow. So you can see control flow while statement import RPI GPIO as GPIO, import time LED equal to 18, and then you have this GPIO dot output LED true, time sleep bracket 1. So while a statement can be used to repeat blocks of cover code over and over again, they are controlled by conditional expression. For example, say you wanted an LED to blink on or off repeatedly, you could use the following code. So this is like to breaking up the loop. Import RPI.GPIO at GPIO. Import time LED equal to 18. GPIO dot set mode GPIO dot BCM. GPIO dot setup LED GPIO dot out I equal to 0. While true, print value of I is now I. GPIO dot output LED true. Time dot sleep 1. GPIO dot output LED false. Time dot sleep 1. I plus equal to 1. If I is greater than 10, then break. To break out of a loop, you can use an statement with break as such, and after I is larger than 10, LED will stop flashing altogether. So conclusion is we have walked through basics on Python programming using the Thorny IDE as well as with the terminals, and we have also briefly looked at the different data types and control flow statement that when we can work on the Raspberry Pi. So that's the I think one, and so now I'll again come back to the this my initial presentation. So these are all mathematical operators like variables. I think I just thought to quickly walk through. Then assignment statements, multiple. I'll maybe a little walk faster here. So now programming using Python operators and expression, binary like addition 9 plus 2 is 11. Addition, subtraction, multiplication, division, integer, reminder. Indentation is important in Python. Grouping of statement, block of statement, no explicit brackets like this to group statement. So x comma y equal to 6 comma 10. If x is less than y, print x, else print y, and print is the minimum. So run the program and then output actually. Nested if else, if a is less than equal to b, if a is less than equal to c, else b is less than equal to c, else then if you have elif a special kind of nesting is the chain of if else. Maybe like if the value of expression pi is less than 2 and 3 by 0 is greater than 1, then runtime crash or error, or if I don't know or I don't care, false or true.
Sir, sorry to interrupt you, sir. Are you sharing the screen?
Yeah.
Because it's not shared, I guess.
Oh, it's not said. So yeah, just a minute. Let me. Sorry, I mean, I think I thought window is said. Yeah, now it is visible.
Yes, sir. It's visible.
Yeah, sure. So I think maybe it's. I think I missed out. Maybe I because switched between one to other. So this is just a like quiz for maybe your interest. You can interpret your answer, and so the correct answer is false. So programming using the Python loop. So this is like a multiplication table, which we know like 5 ja 1, 5 1 ja 5, 5 2 ja 10, 5 3 ja 15. So this is a kind of multiplication table. Now, if you want to run write as a program, So n equal to integer input, enter a number, then print n x like cross is a ja, and then 1 like n into 1, n into 2, 3, 4, 5, 6 like this. But this is like a too much repetition. Can I avoid it? Write a simplified program. So then input n equal n where I equal to 1. If I is less than equal to 10, then true. If false, then stop it. So print n into I is equal to n star I. So I equal to I plus 1. And then you run this loop till 10. And if it does not meet this condition, then stop it. So this is a kind of simplified one instead of writing like table which we had written in the last. So this is a kind of a loop. So now you can see here simplified one like n equal to integer input, n equal to question mark, I equal to 1. Then while I is less than equal to 10, then print n comma x into I equal to n into I equal to I plus 1, and then print done. So this is a kind of a while statement. I'll share this presentation, I think, in the interest of time, because I wanted to cover some portion of last presentation where I had, like I wanted to show a video also. So this presentation, I will stop it here, and then I will maybe last presentation, some portion which is there, I will try to cover up here. I think last time we could not see the video, so that is where I think.
So, hello everyone, and welcome to this Snyder Electric. So he's our speaker today, and I would like to welcome him in. Hello and welcome.
Yeah, thank you, Nicholas,
Thank
for nice introduction. It's pleasure to be with you and all of other audience. So shall we start, or like how to go about?
Yes, I think we can start.
Yeah. So maybe shall I start sharing my screen in that case?
Yes, yes.
Yeah, sure. I'll do that. So now I'm sharing my screen. So hope my screen is visible clearly. Hope audio is audible. Can you please confirm?
Yes, sir.
Yeah, Nicholas, my screen is visible. So I had found a solution to problem last time.
You are audible, but your screen is not.
Oh, screen is not visible. Just maybe I will little skip through, and especially the Nicholas and like other team who has been working in background, and they have made this event happen. So thank you entire team for making this event. So this was, I think, the kind of I think poster which was prepared. So I just thought to take you through. So the next was I will.
Which uses data from connected operations. Schneider Electric opened a new chapter in manufacturing with the launch of a smart factory in Bangalore. Opened with much fanfare, this factory promises a green approach to manufacturing, which will maximize efficiency and promote growth through innovation, where physical machines are fitted with smart sensors connected to a cloud network, which uses data from connected operations and production systems to create spontaneous situations and make real-time decisions. With disruption, digitization, and automation on the minds of every major player in manufacturing, let's take a closer look at what makes Schneider Electric's smart factory solution stand out.
Well, to simply kick off the conversation, and I'd love to start with you. How do technology-enabled factories, smart factories, essentially leave behind existing traditional models of automation that are already in place?
Yeah, I think it's really something important at Schneider Electric because we run 200 factories around the world. We have 100 distribution centers. And let's be clear, all of them are not like have been built last week. So we have plenty of brownfield facilities, and the idea of the transformation that we went through, that I was commenting about earlier, smart factory, smart DC, how they are integrated in the tailored, sustainable, and connected for the zero journey. We do believe at Schneider that we can, I would say, deploy the technology in a way that we can start small and deploy fast and scale up. So in the way that we are able to, implement the technology that Schneider sells to customers, and we do believe that it's the normal approach to use that technology and implement it in our facilities, connecting, I would say, the assets, connecting, the different aspects of the process, and bringing the visibility and bringing the information at the edge control, enabling people operating the workshop, operating the process, the lines, the factory, to have that visibility with the objective of being, safer, with the objective of being faster, with the objective of delivering a better quality for our customers.
Sure. And, Chandrasekhar, I'd love to bring you into the conversation at this point. Building on Murad has just shared, how time-intensive, how capital-intensive is it to transform your existing infrastructure into a factory of the future, into something that is end-to-end technology-enabled? And at what point in the growth story of a company does it make sense to take that step and to pull that trigger?
That's a great question, Pooja. One of the fears that a lot of people, a lot of customers have is, how do I invest in making my factory smarter? The answer to that is, depending on the outcomes that one would map out, an ROI could be as less as a few weeks. It sounds shocking, but it could be a few weeks. Now, I also come from a perspective of being India's largest manufacturer of CNC machines. And in a CNC machine, there are more than 2,000 to 3,000 parts that go into a machine. And a lot of our customers also belong to the SME segment. For them, every paisa or cent that they invest has to have a tangible outcome. And what we believe is a sort of a hub and spoke model where, instead of a big bang, front-loaded approach, we believe that if we take the pains of every department in those companies and we enable them to solve that particular pain and get a certain outcome, then they become the owners of
required as a foundation before we can even
that you projected, there further improvement. So it's really UN
deployment. I mean, that's really the way it goes, because they need to test it. They need to demonstrate the.
There are two fronts on which we
Groundbreaking examples there.
Now, this is where a comprehensive
somehow not using the same approach inside our plants, inside our.
We digitally transform from traditional manufacturing to smart manufacturing by leveraging EcoStruxure solutions, thereby improving our business, safety, reliability, efficiency, sustainability, and connectivity. EcoStruxure platform is Schneider's latest innovation in a decades-long evolution which combines our best-in-class OT solutions with the latest in IT technology. As an open IoT-enabled system, Schneider's EcoStruxure architecture allows us to innovate at every level across connected products, edge control, app analytics, and service for our organization, leveraging our deep domain knowledge and applied experience in 4 end markets. We deploy solutions based on 6 validated reference architectures: building, power, IT, machine, plant, and grid. At the heart of our IoT system architecture is the EcoStruxure platform, connecting everything in our facility from the shop floor to the top floor. EcoStruxure Building Operations is the edge-based application that helps facility manager see real-time data and get early alerts on facility equipment like chillers, HVAC systems, and fire panels, along with live streaming of CCTV footage. Hyderabad site brought under EcoStruxure Building Operations by integrating video expert, security expert, and fire expert in one platform. Under building connected products, plant is equipped with laser-based smoke detector, access door controllers, 65 smart CCTV cameras, fire control panels to sense any abnormal conditions inside the building. EcoStruxure Power Monitoring Expert is the application under edge control layer that is helping our facility to analyze, troubleshoot, predict, and make informed decisions on our electrical distribution network. PME is collecting data from 76 smart meters in the plant from 3 levels of electrical network using 21 gateways and 5 smart links. The different dashboards developed in PME help facility technicians identify abnormal condition with more meaningful and actionable items to act well in advance and take necessary steps to improve power reliability, power quality, and operational efficiency. Resource Advisor at Apps and Analytics layer performs trend analysis, comparison analysis, and calendar load profile analysis. With use of PME and RA tools in Smart Energy Workshop, Hyderabad plant is successful in achieving more than 15% energy savings year-on-year and has won several national level appreciations. IQC is equipped with cutting-edge technologies for measurements of complex profile parts. Critical dimensions are measured and analyzed by instruments such as profile projectors, plating thickness testers with X-ray technology having high accuracy, hardness testers, UTM for load testing, spectrophotometer for color checks. Handling over 4,000 plus parts with storage capacity of 5,000 cubic meter, making it the largest warehouse in Schneider, India. Digital truck management system monitors the complete tracking of the parts from the vendor. Smart ASN receiving process identifies red and green channel suppliers for an efficient put-away process. Separate picking and put-away aisles ensures efficient water spider flow. Water spider efficiency are tracked using LDS tool. Smart Warehouse uses RF scan gun to eliminate manual data entry. The digital e-Kanban system is well deployed for material replenishment. Smart battery charging management is implemented to optimize utilization and availability. As a part of IoT, Connected Machines Initiative, we have enabled all critical machines capable of sending critical to quality and process parameters data to Majoli's Edge Box, which uses node-RED codes to provide real-time data to Insight Online, which helps plot real-time process trends and notify users when processes go out of control. enabling users to take corrective actions. It assists automation experts, facility managers, and technicians in building applications such as monitoring, visualization, and control systems for implementing smart operations across our value chain. On the maintenance front, we have deployed online condition monitoring for critical machines. Condition monitoring application which helps monitor critical machine parameters real time. Notify technicians about abnormalities in machines, enabling timely preventive actions, thereby reducing unpredicted downtimes. Augmented Operator Advisor is used for scanning and comparing the real-time condition of the machine with standards and identify the abnormalities. This helps us to reduce downtime and improve MTTR. In EcoStructure Plant, we have deployed Lean Digitization System, which is a scalable and adaptable operations performance management tool built using IoT concepts. E-and-on system enables us to improve the efficiency and response time of the support functions and provide analysis for identifying continuous improvement opportunities by replacing manual tracking. E-Performance module provides real-time production output and efficiency monitoring. E-Work order management improves service level to our customer through flawless execution of orders, eliminating manual recording. Digital work instruction, which enables us to improve productivity and minimize errors in manufacturing processes. We have installed 3D printer for rapid prototyping. We track critical parts, sub-assemblies, and process parameters against FG serial numbers. These data are digitally recorded through the traceability tool, in which we monitor CTQ and CTP parameters like torque, RPM, angle for each screwing process. Pro QMS module helps to calculate the real-time process capability from the data received from different manufacturing processes. Histogram is automatically plotted X-bar R chart for the critical parameters and sends notifications if process goes out of limit. At any point of time, this data can be accessed and helps to control the manufacturing in a controlled environment. QDIS is implemented for digitizing all checklists for inspection parameters, which will provide Pareto of defects and rejection analysis. Automated guided vehicle for evacuation of finished goods through intelligent routing system with self-learning capability and traffic management system, enabling us to increase support function efficiency. Finished goods are scanned for correct reference and quantity by scanning secondary packaging box. According to shipping list, products are dispatched in closed containers. Akshara, the world-class training center at Hyderabad, which is designed to create and deliver effective manufacturing training programs for the onboarding people. Simulations are used for training, which are an efficient way to demonstrate safety procedures, ergonomy, warehouse operations, lean concepts and quality culture, and more. At the end of the training, the operators will be equipped with familiarization of assembly line before going to Gemba. Digital skill assessment is done using voting pads, Digitest versatility management tool to track and improve the skill levels. The smart factory is equipped with passionate team of close to 1,000 direct employees representing around 19 states from the country, with 2/3 of our workforce being women, which comprises the aspects of health, ergo exercises, cycling zone, leisure, playing indoor games at time to play, and employee-friendly ambience. Schneider always cares for diversity, and especially we at Schneider, Hyderabad, ensures the mother who can happily leave their child at crèche and continue her work and nurse the child at regular intervals. An environment-friendly ambience, and our kids love to be at crèche. Empowering you to maximize energy efficiency and sustainability, optimize asset available and performance, enable smart, productive operations, provide mobile insight and proactive risk mitigation.
analytics and services layer, we have enable this with EcoStructure, our single open IoT system, which allows us to innovate at every level across our connected products, edge control and applications, analytics and services in our facility, with focus on improving safety, quality, reliability, efficiency, sustainability and connectivity. We have deployed EcoStructure Power, where we have connected product energy meter at base level, which collects and distributes information to EcoStructure Power Monitoring Expert, which act as edge control layer, providing real-time power condition at the facility. At the apps, analytics and services layer, we have Resource Advisor, which deliver predictive analytics that will help to ensure all critical equipment and operations are operating safely through continuous monitoring of connected products and bringing in energy efficiency through Energy Action Plan. We have connected all our state-of-the-art PCBA manufacturing critical equipment for monitoring asset utilization and quality performance. Solder-based height inspection machine enable real-time monitoring of solder-based height and volume and calculate first pass yield, Z value, SPC, CP and CPK. In our surface mount pick and place machines, we can predict the performance of the individual feeders and nozzles, which helps to improve the MTTR and the MTBF. Automatical optical placement inspection machine enables real-time remote monitoring of placement offsets, presence and polarity, which helps to control the DPMO. In the reflow soldering machine, each PCBA temperature profile is validated, recorded and compared to earlier sampling process and thus ensure reliable solder joints. Intelligent talking stations. Each tool and every step of talking performance are monitored and recorded, which helps to build analytics to improve talking process robustness and quality at source. We have deployed Lean Digitization System Modules, E&ON system, which enables us to improve the efficiency and response time of the support functions and provide analysis for identifying continuous improvement opportunities. Performance Management Module provides real-time production output and efficiency monitoring, traceability and process interlocks. Our MES client ensures parts quality, MES at warehouse receiving, followed by parts compiled as per Schneider part specification. MES at auto launch point, where all unique serial number assigned to work order with prioritization for complete product traceability as per manufacturing design routing steps. MES at SMT process to ensure right component at right location as per ERP BOM linked to work order. MES at assembly and testing to ensure complete product, component and material traceability with each workstation interlocking. MES at packaging and shipping process to establish individual pallet traceability to work order. QDisc, Quality Digitized Inspection System and Control, is a digitized platform for inspection, audit and SPC module. Additive manufacturing. We have installed 3D printer for rapid prototyping and quick replacement of simple SIG and fixture. Advanced robotics. AGV, automated guided vehicle for material movement at warehouse and evacuation of finished goods at factory through intelligent routing system with self-learning capability and traffic management system. Skill Development Center. At Schneider Electric, in line with high-performance culture, our employees are trained and skilled at our Skill Development Center, Disha. At Disha, there are various digital tools used to impart training on safety, quality, efficiency, and required shop floor fundamental before moving to the shop floor. SE Connect tool, a social and interactive tool to provide a digital experience by connecting and engaging shop floor employees.
In our cooling line, we manufacture a wide range of cooling products with different capacities to meet customer demand, and we also have the capabilities to support exclusive and challenging customer needs. Our lines are equipped with the best-in-class infrastructure and are flexible to cater to precision air handling units and chillers. To add on, we have specialized skill and certified manpower to accommodate and deliver quality products with the best efficiencies. We promote innovation in every step in our design to ensure we meet the market requirements.
Hi friends, in Bangalore, BF Plants, as a part of the Smart Factory initiatives, we have launched an EcoStruxure platform to increase our efficiency and be part of the digitalization program for Schneider Electric. In EcoStruxure, we have EcoStruxure Power, EcoStruxure Plant, and EcoStruxure Machines. Over here, in EcoStruxure Power, we have all our equipments which are giving us the power are connected through a Schneider instruments, and they are collating the data to provide us the efficiency data at what efficiency we are operating at. With the EcoStruxure Power, we are able to generate 22% of the saving in our power consumption compared to the last year, 2017 versus 2018. I must want to emphasize that this platform is giving us huge amount of insights on where we can save power in all our plants in Bangalore factories. With regards to the connected machines, we have connected all our machines, including SMT line, through a line, and also on the manual assembly lines to give us the efficiency data at what efficiency we are operating it, what kind of a quality analytics we can do to drive quality defects in, lower for our products, as well as increasing our plant return ratio. And last but not the least, we have deployed a quality disk, which is helping us to track the real-time data on the quality analytics. This is helping us really drive how we can
So now I will go to the next. So hope I'm audible and you could understand like kind of product.
For the supply chain performance group with Schneider Electric. I'm excited to have you here today in Lexington, and I'd like to talk to you a little bit about a digital transformation that we've performed here in an aged facility, a facility that's 63 years old.
So this is a like 63-year-old factory which has been made a smart factory.
And how we achieved or went through some of the roadblocks to perform that digital transformation.
So we're now on the factory floor. We're standing here in our customer welcome center in the Lexington facility. We make load centers and safety switches here in the Lexington facility, QO and home line load centers for energy distribution, commercial and residential applications, and safety switches in single phase, three phase, varying in size from 30 amp to 200 amp varieties here in the facility. We are fortunate enough to be fairly vertically integrated in this facility. All of the high tonnage stamping, the plastic injection molding, the electroplating for the coating on our current carrying devices, the semi-automated assembly, the painting.
So I just want to make a point here. You had seen earlier two factories. One is smart factory in Hyderabad. And another smart factory in the Bangalore, which is for electronic product, and a smart factory in Hyderabad is for electromechanical product. So you had seen that, and now this third example is from Lexington, which is in USA, because Schneider historically acquired the Merlin and kind of Square D, which was part in the US. And the US factory is the oldest one. So the example here given is like how the oldest factory also has been transformed into the smart factory, while India, we has a big advantage because we had created the structure or infrastructure right from beginning. So we are smart factory from day one itself, while the age-old factories, they are going to upgrade, and it becomes a Herculean challenge how to upgrade the old factories. So the problems are different there, and India has a unique advantage of being a newest infrastructure right from beginning as a smart factory. So with that, I will continue further. Thank you.
Of the metal itself and the semi-automated assembly, and even the material conveyance from fabrication all the way through the assembly line is under one roof. We're also fairly highly automated in the fact that we make approximately 2.8, nearly 3 million of these devices a year in this facility from a raw coil of steel, and we're making a little over 800,000 of these safety switch devices in the facility. We've progressed through the plant now to the point of our first station stop where I want to talk about unlocking siloed data. We noticed that we had concentrations of tribal knowledge in the facility, particularly around the knowledge that it takes to troubleshoot the pieces of electronic devices that control our machines, PLCs, PCs, documentation and information on that machine, critical health signals from that machine is difficult, requires a special skill for a person to come, hook a laptop up to a device to troubleshoot it, spend time trying to find documentation. We've implemented an augmented reality application here known as EcoStruxure Augmented Operator Advisor. And what EcoStruxure Augmented Operator Advisor has done for us is using the power of Node-RED, we've been able to unlock that data out of that PLC and deliver it in a real-time image, overlay that data in a real-time image of an actual camera view of a mobile device, such that now a technician or a maintenance mechanic or a supervisor or an operator no longer needs to rely on that tribal knowledge to connect the programming device to debug or troubleshoot. They merely hold the tablet over their equipment and the critical data pops up in real time and streams live. It's been very exciting for us and is delivered through our Wi-Fi network in the plants to our mobile devices. And let's take a look at one of the 16 different pieces of equipment that we've implemented this tool on, and let's see how it's delivered to us about a 20% reduction in mean time to repair. I want to talk about two of the most important connected products that this facility has in terms of its digital transformation or its digital evolution. The first of which is the Aussie Sense offering, the Aussie RFID offering from Schneider Electric. The conveyor system, at any given time, we move over 7,000 parts in the sky from a fabrication group through paint and to the final assembly group in the right order, in the right priority, at the right time to the assembly line. Another very critical connected product for us that we have over 300 of in the facility are the Magellus HMIs. And you'll see those quite frequently throughout the plant. It gives all the operators the ability to visualize, to control their processes in the plant. We rely on them very heavily. This device also has the ability, through the use of two advisor applications known as Secure Connected Advisor and Mobile Operator Advisor, the ability to deliver a cyber secure connection to any device that's on the subset of this device. It also gives you the ability to deliver control anywhere in your facility of the actual HMI screen through the use of Mobile Operator Advisor. So we use these throughout the facility. In this particular case, in our Power and Free system, we can look at information streaming from anywhere in the facility, from any one of our processes. This particular Power and Free system that we're standing in front of now has 8 different control panels like this and over 30 HMIs in the system that we can view what's going on across the plant and see from any individual location in the plant. And those are very powerful for us. So we're coming to a very critical process in the Lexington facility, and that's our paint room. You can understand with a process that's this complex, you know, a 7-stage pre-treatment system, 20,000-gallon e-coat tank, the ability to e-coat 50 million square feet of metal a year. You can understand the complexity and the amount of control and monitoring that needs to take place. So what we've implemented here in our paint system is we've implemented a solution known as EcoStruxure SCADA Expert based on Intusoft Web Studio, which has given us the ability to visualize and control 167 critical variables in the operation. Now, the really cool thing about the Intusoft Web Studio or EcoStruxure SCADA Expert application is its use of mobile thin clients and web thin clients to deliver that content anywhere in the building. What we're looking at here is we're looking at a live operator view of what the operator is using in the facility to control the processes. If you look through the control room here, you'll see another screen that looks exactly the same because this is a secure web client that has delivered this view or this input into this process in multiple locations throughout the video. So we're at a point in the tour now where I'd like to talk to you about our digital energy management system here in Lexington, Kentucky facility. We utilize two very important tools, one an edge tool and one an app and analytic layer tool. The edge tool is known as Power Monitoring Expert. Power Monitoring Expert lies here at the edge and uses a system of connected meters in your facility to tell us exactly where your energy usage occurs. It also has the ability to extract data from PLCs and PCs, and it lets you descriptively analyze comparisons of that connected meter data with certain things like empty hooks in our paint system, the different types of metal that we use in our plant, gas consumption on a particular day. Gives you the discrete ability to descriptively analyze and dashboard your energy usage in a particular area with very great detail. Then at the regional level, in a cloud application known as Resource Advisor, we extract, our regional operations managers extract these cloud application data as a Power Monitoring Expert to the regional level, and they're able to do plant-to-plant comparisons across Schneider Electric. So for an entire region, we can analyze what we've spent and where we've spent that type of money, compare that to trends in weather, compare that to trends in year-over-year trends or month-over-month trends. Now, the use of this Power Monitoring Expert at the edge and this Resource Advisor at the cloud for a regional look, to give you an idea of how we've impacted our facility, Power Monitoring Expert has delivered us over 20% in energy reduction savings since its installation, over a 70% reduction in our carbon footprint or CO2 production. It's also given us over a 5% year-over-year energy savings reduction, and we're on here in Lexington. I want to thank you for being here with us, Schneider Electric in Lexington, and I ask that you come to the plant when you can in person, and maybe we'll see you then and tell you how we've developed more of our story. Thank you very much.
Get the experience from the industry and from various to consider industry and giving our
So with this, I think, my presentation and my, smart factory, like details, what I had said, which is like plant details. So both are complete. And in case of any question or query, you are most welcome.
Participants, please ask query. more questions.
Okay, thank you very much. And
Hello. Thank you so much, respected BL Bishnoi sir, for your detailed insights. Hello. Sir, hello. Hello, hope. Am I audible clearly?
yeah, we are able to hear. Yeah.
Yes, sir. Thank you so much, respected PL Bishnoi sir, for your detailed insight towards the Raspberry Pi, its implementation, uh, the programming, youth, is what are the care should be taken while programming the Raspberry Pi. And in the last, the video you have you have shown, those were really the nice example of the usefulness of the Raspberry Pi in the future ahead. Thank you so much, sir,
Yeah, thank you very much
for being with us in our this IEEE sponsored, IEEE Bombay sponsored FDP. Thank you so much, sir. Thanks, dear participant too. I request all to please switch on your video so that we can get a group photo.
Yeah, sir.
Ready, sir? Participant, please switch on your camera. One more, sir.
Okay.
One more, huh, sir. Yes, done. Thank you so much. So we are ending the session here. Thank you so much, sir. Bishnoi, sir.
Yeah, thank you very much. Thank you very much, Vijay Chaudhary ji, and maybe all the audience. Appreciate for your patience hearing and time investment here. I am sure it was useful and you could.
Yes, sir. It's a pleasure to be with you, sir.
Yeah,
Yes.
sure. Thank you.
Thank you, sir.
Yeah, welcome.
Ma'am, I'm closing the session.
Thank you. Yeah, okay.